humans are able to do that. So you train a machine to be able to do that. Are we together? So artificial intelligence just ends up translating machine learning into tasks we see only humans being able to do what? To do. Are we together? But we shall get back to that. Let me first move through that quite fast. So let's start with machine learning. Why am I starting with machine learning? Because I can't take away machine learning from artificial intelligence. We've at least appreciated what AI is. Sorry, what data science is. The science about data, and we are saying that when we are able to collect enough amounts of data, then we can use that data to do what? To build intelligent machines. We make machines able to recognize patterns. Are we together? What are some of the common concepts that we see? Supervised learning. We can train machines to do what we call learning, but when we are doing it in a supervised way. Are we together? We have unsupervised learning, and then we have cosmic learning. I'm not going to go so much in the details of this, but I'm just going to give you examples. With machine learning, we mentioned supervised learning. We are talking about, let's say we've gone back to primary and we are talking about abacus, numbers. Who of you remembers that time when we first stepped in class? May I still remember my very first day in class, and I was 2.5 years old. I don't remember anything else about my childhood, but I remember that. I remember that scenario. I left home, putting on a white shirt, black shorts, sat in class. So things I didn't understand, but at least I remember that instance. Who remembers any of that information? You probably don't remember, right? Now, I want to use that as an example of supervised learning. I don't know if you can bring it out, but in supervised learning, what you do, you get examples. Are we together? You get examples. Those examples of math where they will teach you in class, 2 plus 2 is in. So when we were in those younger classes, they would add for us. 2 plus 2 equals to 4. Then they show you how you calculate the 2 plus 2. They tell you, get 2 oranges. Are we together? And other 2 oranges, bring them together. Then count how many oranges you have in what? That gives you 4 oranges. You get it? They didn't start by telling you 2 plus 2, but they used an example, you know. 2 oranges plus 2 oranges, you end up with 4 oranges. 1 orange plus 3 oranges, you get 4. Are we together? Now, there is some pattern in what you're doing. The pattern is, when I combine the number of things here with the number of things here, I get a total. You get it? So when you do that on 1 plus 1, you do the same on 2 plus 2, 3 plus 3, 4 plus 4, 5 plus 5, then you need maybe 5 plus 6, 2 plus 5, like that and that. You start knowing that, oh, whenever there is a plus sign, and I have a value here and a value here, I bring those values together and I end up with what we call the total, or the sum. Are we together? Now you use those examples. 2 plus 2, it gives you 4. 1 plus 1 gives you 2. Use those examples. You give those examples to a machine. Then the machine starts knowing that, oh, when I see this value and this value, the answer is this. Now when I bring in new data points, are we together? Where there is no 2 plus 2, but I bring a data point like, let's say, 20 plus 1, then the machine is able to remember the 20, then the plus, and then the 1, and it gives me an answer which is 21. Basically, I teach a machine to do what we call prediction. But I first give it historical information. This is very common when we are training machines. You basically get historical information. Are we together? Then use that historical information to make a machine see patterns. Now, when you bring your new information, the machine is able to use the patterns it learned, are we together, to now think and give you an answer. That's what teachers used to do for us. They give you an example that looks easy, an example, You do the example, 2 plus 2, and then in the exam they bring 100 plus 500. Are we together? So your brain is now being taught through supervised learning. They first gave you examples. Are we together? With the hope that in the examples they gave you, you learned the patterns. Not that you cram. People that, you guys know math. Can you cram math? Do we have anyone here who does calculus? Calculus. Can you cram math? You can't but you use the same word. The same formula. Formula doesn't change. But they always give you different kinds of questions. Are we together? Therefore, in supervised learning, you don't have to cram. The machine doesn't have to cram. It just has to learn the patterns. Are we together? When it learns the patterns, the machine can be able to do classification work. Classification work. The other example I gave you of coming here and I'm able to tell that, oh, she's a lady, he's a gentleman. Are we together? I did supervised learning if I was a machine by seeing very many examples of ladies and gentlemen. And I learned patterns. So she doesn't have to be like the same lady that I saw yesterday. It doesn't have to be the gentleman I saw yesterday. But the fact that I have done a lot of examples of gentlemen, then I can tell that this is a lady, this is a gentleman. That's what we call supervised learning. And we always use it in classification problems. Are we together? We have regression problems of prediction. If the weather on Monday is, if the Monday of every week we receive rain at around 1 p.m. Are we together? And that happens for like 10 different Mondays consecutively. Will you pick a jumper on the 11th Monday when you're coming? You'll pick a jumper. Why? Because you've seen patterns that on every Monday rain comes at 1 p.m. Are we together? So the 11th Monday you'll come with a what? With a jumper. That's what we call supervised learning. It helps with classification problems and regression problems. Then we have unsupervised learning. Unsupervised learning is not about identifying male or female, no. Unsupervised learning is about a system that is able to differentiate things that are not similar. So it must be able to see patterns that tell it that, oh, A is different from B. Are we together? It doesn't need to have an example. You don't have to have given the system an example, but you give it data and then it studies the data. After studying the data, it goes ahead and says, oh, from this data that I've been given, this ruler is different from the other ruler. Maybe one is a long ruler and then the other is a protractor. Because of the differences in the data that it has taken in, are we together? I'll just use an example of unsupervised learning. With unsupervised learning, we always see or interact with unsupervised learning when we are dealing with algorithms on social media platforms. I'm not on TikTok, but I know TikTok is one of the best systems that have been built that utilizes unsupervised learning. Because if you watch one TikTok video, you get one TikTok video. Let's say the TikTok video is talking about AI, right? And then you search another TikTok video talking about AI. The next time you scroll your TikTok, you're more likely going to see more videos about what? AI. Are we together? Why? Because this system has been trained by you yourself that you're interested in AI. Are we together? So it starts gathering information about AI and brings you information about AI. And then information that is not about AI, it takes it away. Are we together? Next time you change your search algorithm and you start looking for other things, it will bring those things. That's what we mean by a system that is what? That is unsupervised. It simply looks at patterns. This one, whenever they go on YouTube, they're ever looking for highlights of, let's say, football. Are we together? They're looking for highlights of Barcelona. Okay. Today you search something about Barcelona, tomorrow Barcelona, the other day Barcelona. Now every time you log into your YouTube, you're going to be seeing what? Barcelona highlights of Barcelona information. Why? Because the system has learned that for you, those are the things that work. That's unsupervised learning. And we always use it in problems of clustering. Are we together? Clustering. I may use unsupervised learning, by the way, to still differentiate between a male and a female. I'm using that example because it's the best example that I can use from this room here. Are we together? There's some information we can collect about females. We give it to a computer, and information about males. But we don't tell the computer that A was a male, B was a female. Are we together? But then the computer will be able to tell, like, whenever I get to this part called the head, for the female, they are braids. Are we together? See an individual that has braids, the conclusion is what? That is a female. Are we together? And then the other is a male, the one without braids. That's what I mean by unsupervised learning. You never told the system that you're dealing with a male and a female, but it differentiates between the two by the differences they have in their data. Are we together? There's something we call dimensionality reduction. This is a, but you can first read that. Then another last important concept that we always look at in machine learning is known as reinforcement learning. This is the closest form of learning to the way humans learn. Humans learn with what we call insight. Insight is the other thing he told us, where you are able to reason. I think it was the lady who told us about insight. It is about reasoning. Now, reinforcement learning is when a machine learns through what we call try and error. Let me give you an example. Who of you has a young sister at home? Maybe 1 year, 2 years, 3 years. Who of you has? And who of you has a sister, or a sister, a nephew, a niece, a brother that is very young? Who of you has? I would send you and do an experiment on them because they are still too young. They need to learn some of these things. But this is what I mean, even if you don't have, but let me use it in another context. When you were young, the best way of teaching that infant not to touch something hot is by letting them touch something hot. Are we together? If you tell a young kid that please don't touch that flat iron, yeah, that young kid will go ahead and touch the flat iron. Are we together? But if they touch the flat iron by themselves, even when you don't tell them and it burns them, guess what they are going to do? Are they going to touch it? Are they going to touch it again? Are they going to touch it again? No, they are going to do what we call learning by punishment. Are we together? Now that's what we mean by reinforcement learning. With reinforcement learning, a system learns through punishment and rewarding. Rewarding, when a good act is done, the system gets a reward. When you do a bad act, you get punished. So you learn that the more I do this, I get rewarded. You do the behavior that whenever you use ChatGPT, are you guys following? Whenever you use ChatGPT, sometimes they can give you sit down there after you've prompted it and you've gotten a certain response. When you check down there, they give you two options. An option of liking the answer and an option of not liking the answer or the response. When you click, you've liked that response, you've trained the algorithm that whenever it writes the way it has written for you that response, you like that. Are we together? And if you click on this thumbs down button, you're training the system that whenever you write such kinds of answers, I don't like them. So you are training the system through punishing it and rewarding it. Are we together? That's how reinforcement learning works. And those are the three let me see.